Picture this. You're sitting there right now watching this video, and you feel absolutely certain that time is passing. You can feel it. Every second that ticks by is real. The past just happened, the future is coming, and you're riding this wave called the present moment. But what if I told you that Richard Feynman, one of the greatest physicists who ever lived, looked at the equations that govern our entire universe and realized something absolutely mind-bending: time, as you experience it, might not exist at all. Not in the way you think. And before you click away thinking this is just philosophical nonsense, understand this. The mathematics doesn't lie. The equations that describe everything from the smallest quantum particle to the largest galaxy, they don't distinguish between past and future. They don't care which direction time flows. In fact, they barely recognize time as flowing at all. So what's really happening when you feel time passing? By the time we're done here, you're going to understand why the greatest minds in physics keep saying time is an illusion, and more importantly, what's actually real underneath that illusion. Trust me, the answer is far stranger than anything your common sense could prepare you for. Let's start with something that seems completely obvious. This morning, you woke up. You remember what you had for breakfast. Maybe you're planning what you'll do tomorrow. This feels natural, right? The past is behind you, gone, finished. The future hasn't happened yet. It's waiting out there somewhere. And you're trapped in this razor-thin slice called now, being pushed forward like a leaf in a stream. Except here's the problem. That stream, it might not exist. And that now you're experiencing, it's not what you think it is. Let me show you why your common sense picture of time falls apart the moment you actually examine it closely. Ask yourself this simple question: what does now mean? You might say, well, now is right now, this exact moment. But hold on, what about now on Mars? Mars is about 12.5 light minutes away. If something happens on Mars right now, you won't see it for 12.5 minutes. So which now are we talking about? The moment it happens there, or the moment you see it here? You might think, okay, that's just a communication delay. Light takes time to travel. That's not really about time itself. But Einstein discovered something that completely destroys this comfortable explanation. It turns out that now isn't just difficult to coordinate across distance. Now is actually different for different people, even when they're trying to measure the exact same events. This isn't a problem with our clocks or our measurements. This is reality. Here's what Einstein figured out, and pay attention because this is where everything changes. Imagine you're standing on a train platform. A train screams past you at tremendous speed. At what seems like the same instant, lightning strikes both ends of the train, front and back. You're standing right in the middle of the platform. You see both flashes reach you at exactly the same time, and you conclude those lightning strikes were simultaneous. They happened at the same moment. But there's someone sitting in the middle of that moving train, because the train is racing toward one lightning strike and moving away from the other. The light from the front reaches her first, and the light from the back reaches her second. Now here's where it gets absolutely wild. She doesn't just see them at different times. According to all her measurements, with clocks and rulers that are just as valid as yours, those events actually happen at different moments. The front was struck first, the back was struck later. So who's right? You, standing still, saying they were simultaneous, or her moving, saying they weren't? Einstein's answer shattered 300 years of physics. You're both right. Let that sink in for a second. Two people observing the same events disagree about whether they happened at the same time, and both are correct. Simultaneity, the idea that two things happen at the same moment, depends on how you're moving. There is no universal now that everyone in the universe shares. And if that's true, then everything you think you know about time is built on sand. Because if we can't even agree on what now means, then how can we say the past is gone and the future hasn't happened yet? If your now cuts through the universe differently than my now, then maybe, just maybe, all moments exist equally, and we're just experiencing different slices of them. Physicists have a name for this idea, the block universe. Imagine all of history, everything that has ever happened and everything that will ever happen, laid out like a giant four-dimensional sculpture. Every moment is a location in this sculpture. The Big Bang is there. The dinosaurs are there. Your birth is there. This conversation is there. Your death is there. Everything exists all at once, frozen, eternal. Now I know what you're thinking. That can't be right. I can feel time passing. The past feels different than the future. But here's the thing. In the block universe, past and future aren't fundamentally different. They're just different directions, like north and south. You don't say that Los Angeles doesn't exist because it's west of New York. They both exist, just in different locations. In the block universe, the year 1950 and the year 2050 both exist. They're just in different locations in the time direction. Your experience of moving through time, that feeling of now sliding forward, isn't the universe changing. It's you, your consciousness, your memory, moving through a structure that's already complete. Think of it like a movie. When you watch a film, you experience the story unfolding moment by moment. The beginning happens, then the middle, then the end. You feel the narrative flow. But the actual film, the physical object, it's just sitting there complete. All the frames exist simultaneously on that strip of film or in that digital file. The whole story is there at once. When you experience it frame by frame, that's just how your mind processes it. The block universe is like that film. Your entire life, from birth to death, exists all at once in this four-dimensional structure. But your consciousness experiences it moment by moment, creating the sensation of time flowing. The flow isn't in the universe. The flow is in how you're built to perceive it. Now, if this sounds crazy, good, it should, because we're about to go deeper. If the block universe is real, if past, present, and future all exist equally, then here's the question: why does time feel like it has a direction? Why do eggs break but never unbreak themselves? Why do buildings crumble but never spontaneously rebuild? Why do you remember yesterday but not tomorrow? This is called the arrow of time, and here's the shocking part. It's not in the fundamental laws of physics. Watch this. If I film two billiard balls colliding and then play the video backward, the backward version obeys Newton's laws perfectly. There's nothing in the mathematics that says this direction is forward, this is backward. The same is true for Maxwell's equations describing light. The same is true for Einstein's equations describing gravity. Even quantum mechanics, at its core, works the same forward and backward. So if the laws are time symmetric, if they work equally well in both directions, where does the arrow come from? Why does the universe seem to have a preferred direction when the rules governing it don't? The answer is something called entropy, and this is where things get beautiful and strange. Entropy is a measure of disorder, of how spread out and mixed up things are. Here's a simple example. Imagine a box with a partition in the middle. On one side, you've got 100 gas molecules all bunched up. On the other side, nothing. You remove the partition. What happens? The molecules spread out. They fill the whole box evenly. That's an increase in entropy. Now here's the key question. Why don't the molecules ever spontaneously bunch back up into one corner? It's not because the laws of physics forbid it. In fact, if you filmed the molecules spreading out and played it backward, that backward movie would obey all the laws of physics. The molecules could bunch up. It's allowed, but it never happens. Why? Because there are vastly more ways for molecules to be spread out than bunched up. If you shuffle a deck of cards randomly, you could get any arrangement. But most arrangements look random. Very few arrangements are special, like having all the suits perfectly ordered. So if you keep shuffling, you'll almost always go from order to disorder. Not because disorder is more fundamental, but because it's statistically more likely. There are just more ways to be disordered. And here's the crucial insight that explains everything. The universe started in an extraordinarily low entropy state. The Big Bang wasn't just hot and dense. It was incredibly uniform, incredibly ordered in a gravitational sense. And ever since that moment, entropy has been increasing. The universe has been spreading out, mixing up, falling apart. This is the arrow of time. It's not built into the laws. It's a consequence of where we started. We're living in a universe that began with very low entropy, and we're sliding downhill toward higher entropy. And that gradient, that slope from order to disorder, is what gives time its direction. That's why eggs break. That's why you age. That's why you can remember the past, but not the future. Memory itself is a physical record, and creating a record always increases entropy. You can't form a memory without changing the physical structure of your brain, and that change is an entropy increasing process. So the direction of time, this thing that feels so fundamental, so obvious, isn't in the equations at all. It's an accident of history, a consequence of the special state the universe happened to start in. But now here's where we need to be really careful, because we've explained why time has a direction, but we haven't explained why time feels like it's flowing. Why do you feel like you're moving through time? Why does the present moment feel so vivid and real, while the past feels like a memory and the future feels uncertain? And this is the part that might make you uncomfortable, because the honest answer is that feeling might not correspond to anything in the physical world at all. It might be entirely a feature of your brain, of consciousness. Think about how your brain actually works. Right now, photons are hitting your eyes. Sound waves are hitting your ears. Your brain is taking all that information, processing it, integrating it, and constructing what you call your experience of the present moment. But that construction, by the time you're aware of something, it actually happened a tenth of a second ago or more. Your brain even rearranges events, adjusting their timing to make them seem coherent. If a flash and a sound happen very close together, your brain might make you experience them as simultaneous, even if they weren't quite. What you call now is actually a carefully edited summary of the recent past. So maybe the flow of time is a user interface. It's a way your brain represents the fact that some things cause other things, that there are sequences, that there's change. That there's change. Your brain needs to track what's happened so you don't repeat mistakes. It needs to predict what's coming so you can act. And maybe the sensation of time flowing is what it feels like from the inside to be that kind of information processing system. It's not telling you something deep about the structure of reality. It's telling you something about how you're built. Now, some people hear this and they feel cheated. There's the faxes bursation. They say, wait, are you telling me time is an illusion? That my experience of time passing is just my brain lying to me? But calling something an illusion doesn't mean it's not real. A rainbow is an illusion in a sense. The colors aren't actually out there in the sky. They're created by your eye and brain responding to light of different wavelengths. But rainbows are still real phenomena. You can photograph them, you can study them. The experience is real. It's just that what you're experiencing isn't what you thought it was. Time is like that. The feeling of time passing is absolutely real. The experience is genuine. It's just that what's actually happening might not be you moving through time. It might be your brain constantly updating its model of the world, laying down new memories, making new predictions, and that whole process feels like time passing. Now let me tell you about something that blows my mind every time I think about it. When physicists try to write down a theory of quantum gravity, combining quantum mechanics with Einstein's general relativity, they run into a famous problem. In normal quantum mechanics, there's an equation called the Schrödinger equation that tells you how quantum systems change over time. Time is explicitly it tells you, here's the state now, here's how it evolves to the next moment. But when you try to write a similar equation for the entire universe, including gravity and space-time itself, something bizarre happens. The equation you get is called the Wheeler-DeWitt equation, and the time variable disappears. It's just gone. The equation describes a universe that doesn't evolve in time at all. It just is, timelessly. Now, physicists argue about what this means. Maybe it means time is emergent, that it arises from something deeper. Maybe it means we're writing the equation wrong. But the fact that our best attempts to describe ultimate reality keep bumping into timelessness, that should tell you something profound. Time, as we experience it, might not be fundamental. It might be like temperature, real and important at our level, but not part of the deepest description. So let me try to put this all together, because I know I've thrown a lot at you. What is actually happening? The universe isn't a story unfolding in time. It's more like a four-dimensional sculpture, a block where all events coexist. Different observers slice through this block differently. There's no universal now. Within this block, there are patterns, structures, relationships. Some events influence other events. We call the influencing ones causes, and the influence ones effects, and we call the direction from cause to effect the arrow of time. But that arrow isn't fun. It emerges because the universe started in a special low entropy state. Entropy is increasing, memories are being formed, things are falling apart, and that creates the arrow. The feeling of time flowing, of being in the present moment, moving toward the future, that's what it feels like to be a conscious being embedded in the block. That's what it feels like from the inside to be a memory-forming, prediction-making creature. The flow is real as experience, but it doesn't correspond to anything in the fundamental physics. The universe doesn't flow, we do. Now you might be wondering, why does any of this matter? Why should you care that physicists think time is strange? I think it matters because it changes everything about how you see yourself. If you think time is a river carrying you from birth to death, then existence feels fragile. The past is lost. The future is uncertain. You're clinging to this moving present moment, and it's slipping through your fingers. But if the block universe is true, your whole life is there. Your childhood isn't gone. It's at a different location in space-time, but it exists just as much as this moment does. Your future isn't unwritten. It's there. You just haven't experienced it from your current position yet. This doesn't mean you know what your future is. You still don't. And it doesn't make your choices meaningless. You still have to live through it. But it might change how you think about regret and loss and hope. Einstein understood this deeply. When his lifelong friend Michel Besso died, Einstein wrote to the family, "Now he has departed from this strange world a little ahead of me." That signifies nothing. For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion. Think about that. Einstein wasn't being cold. He wasn't denying grief. He was pointing to something larger. In the block universe, Besso still exists at an earlier location. In the deepest physical sense, nothing is truly lost. The pattern is still there, eternal, unchanging. We, moving through our slice of it, experience loss, but the universe doesn't lose anything. It simply is. All right, and maybe that's the most liberating thing you'll hear today. You're not a fragile creature being swept along by a river you can't control. You're a pattern in the fabric of space-time itself, as real and permanent as anything else in the cosmos. Your life, your experiences, your consciousness, all of it is woven into the structure of reality. The block doesn't care whether you're experiencing what you call past, present, or future. It's all there, all real, all eternal. We experience it sequentially because that's how consciousness works. But the thing being experienced, the actual structure of the universe, it's timeless. So the next time you feel time flowing, pause. Appreciate the strangeness of what you're feeling. You're experiencing the intersection of physics and consciousness, The place where a timeless block meets a brain that creates the sensation of now. And that intersection, that flickering awareness you call your life, might be the most remarkable phenomenon in all of space-time. Because the universe doesn't need time to exist, but you need the experience of time to be who you are. And that makes it precious beyond measure.